In this example, we need to describe a sequence of transformations which maps the graph of y equals log x onto the graph of y equals 8 minus e to the x. Let's first think about how we can get from y equals log x to y equals e to the x. We know from earlier in the course that a function and its inverse are reflections of each other in the line y equals x. And that's useful here because log x and e to the x are inverse functions. So our first transformation will be a reflection in the line y equals x. That will get us from y equals log x to y equals e to the x. Next, we need to get from e to the x to minus e to the x. To do that, we'll reflect in the x-axis. A reflection in the x-axis tells us to replace y by minus y. Multiplying both sides by minus 1 gives y equals minus e to the x. Finally, we need a positive 8 on the right hand side, so we'll translate by the vector 0, 8. That tells us to replace y by y minus 8. Adding 8 to both sides gives us y equals 8 minus e to the x. So that's one possible way of doing this question. We'll just review one other where we do the transformations in different orders. We'll stick with the reflection in the line y equals x first, but this time we'll do the translation first. But instead of translating by 0, 8, I'm going to translate by 0, minus 8. The reason for that will hopefully become clear later in the question. Here we replace y by y plus 8. Subtracting 8 from both sides gives us y equals e to the x minus 8. You may notice here that the signs of the two terms I have on the right hand side are opposite to the signs I want in my final result. So a sensible next step is a reflection in the x-axis. That tells us to replace y by minus y. And then multiplying both sides by minus 1 gives us y equals 8 minus e to the x. Okay, here's one for you to try for yourselves then. If you find it quite easy, you might want to make it more challenging by seeing how many different combinations of transformations you can find to solve the problem. For example, instead of doing your stretch and translations in the same direction, can you find an alternative way of doing it in perpendicular directions? Also, you might want to experiment with what happens if you change the order in which you do the reflection in the line y equals x. So, pause the video and then come back and check your solution against mine. Welcome back. Here are two of my solutions. In the next part of the video, I'll briefly review the two solutions you can see on the screen, and then following that, we'll explore what happens if you try and do your stretch in the y direction. So for our first combination, we need to get from the cube root of x to x cubed. Y equals the cube root of x and y equals x cubed are inverse functions, so we reflect in the line y equals x. Then, to get the plus 1, we apply a translation of vector minus 1, 0. That tells us to replace x by x plus 1. Then, to get 3x, we apply a stretch of scale factor 1/3 in the x direction. An alternative combination is to reverse the order of 2 and 3, although this will affect the translation. So we'll stick with the reflection in the line y equals x first. We then apply a stretch of scale factor 1/3 in the x direction. That tells us to replace x by 3x. Then we need to apply a translation. But this time, anything we replace x by is going to be multiplied by 3. So if we want to have a plus 1 here, then we need to translate by minus 1/3 in the x direction. This means we replace x by x plus 1/3. Multiplying out the brackets gives the required result. Let's now have a think about how we might instead do a stretch in the y direction. I'm going to be modifying our result on the right hand side here. And instead of doing this stretch of scale factor 1/3 in the x direction, I'm instead going to stretch in the y direction. To think about what the scale factor will be, I want you to think about this bracket here with 3x in. If we were to expand out this bracket here, we would end up with 27 multiplied by x cubed. And so instead of stretching scale factor 1/3 in the x direction, we could actually apply a stretch of scale factor 27 in the y direction. This stretch would then give us the same result for step 2, which means we could then apply step 3 just as we did before. So that's a third alternative. But then we can use the fact that if this is a stretch in the y direction, and this is a translation in the x direction, we could then reverse the order of 2 and 3, and we would have another possibility that would work. So that shows us that there are at least 4 solutions to the problem.